So the first case of no slip condition, if we have a wheel on a fixed horizontal surface, instantly we know two things. We know the velocity, we know the acceleration at point C. So whenever you do homeworks or exams, you see that words, no slip, the first thing you should write down on your solution is, this is a case one, no slip, and this is the velocity, this is the acceleration at contact point. Okay. We have another case, case two. For case two, it's you have a wheel. Instead of have this wheel on a fixed surface, this wheel is sitting on a block. This block is sliding on a fixed surface. The block B, let's call that block B. Block B can move on the horizontal direction with velocity VB and acceleration AB. All right, this is a case two. When wheels rolling without slipping on B, B is moving on X direction. So this is a second case for rolling without slipping. And this case is a little bit more complicated than the first case. Well, the special point is still the contact point C. So can you guess what is the velocity at point C? Is that 0 again? In this case, in case 2, the velocity at point C equals velocity of B. So VC on X direction equals VB. VC on Y direction equals 0. That's the velocity at point C. You can write this as a vector. VC can be written as VBI plus 0J. Yeah, the contact point, point C, it depends on how fast that block is moving. We also know something about acceleration at point C. So AC on X direction is the same value as AB, how fast that block is moving. No, acceleration of that block B. ACY equals question mark. Okay, for acceleration of CX equals how fast that block B is changing in speed equals AB. But for ACY, the acceleration on Y direction is question mark. What does that mean? That means I don't know. You don't know. No one knows. You need to do calculation to find out what that number is. There's no fixed equation for that number. So we don't know. Don't assume you know. All right, now let's write out what's the acceleration for AC in vector form. AC is going to be ABI plus, all right, question mark, we don't know, J. That means we want to, in order to find acceleration at C, we need to solve those. Okay. So far, this is the second case. Case 1 and case 2. Whenever you see no slip, always refer that back to case 1, case 2, determine which case are we looking at. If that is case 1, write down everything we know under case 1. If that is case 2, write down those equations for case 2. Okay. Now let's look at an example to see how do we utilize these two different cases. If you have textbook, it's on your textbook example 2A6. Okay, Josh, do you mind read this for us?
The cable was wrapped around the end of radius of the spool, and the end of the cable was moving to the right speed of v sub a. The spool was able to roll without slipping or roll forward on the surface. Find the velocity of the center of the spool and the angular velocity of the spool.
Thank you.
Use the following parameters in your analysis. We say assume 2 seconds, r equals 24 meters, and r equals 0.8 meters. Also, be sure to express your answer as practice.
In this case, we have a spool. The spool has two radius, the inner radius and the outer radius. Okay. And we have a contact point, point C. And the keywords is no slip. Yeah, how do we solve this problem? Find VO and omega. First, look at this problem to determine which case are we looking at here. Is that case 1 or case 2? It looks like case 1, right? We have a wheel on fixed horizontal surface. That's our case 1. Okay, now we know it's case 1. Check your notes and copy all the things we know from case 1. Yeah, this is case one. So instantly we know those information about the contact point, point C. Okay, what's next? We want to find omega and VO. So we know something about point C, and we also know the velocity at point A. Let's call that point A. We want to find omega. Where did we learn omega again? Where can you find omega? In which equation? Yeah, both velocity and acceleration equation has omega, but that velocity equation looks simpler. Can we use that velocity equation to solve what is omega? Instead of that velocity equation, we need to know the velocity at two different points on the same rigid body. Do we know 2 points that we know at velocity? Yes. We know point C, we know point A. Can we use these 2 points for the velocity equation? Let's try that. Velocity equation, VA, build a relationship between VA and VO, VC. Right, that's the equation we learned last Friday. On same rigid body, that's how we build a relationship between velocities at two different points. VA equals VC plus omega cross product R. Okay, I purposely leave something blank and did something wrong. So can someone tell me what is missing here? AC, where's AC? Should be RA/C. Yes. What is that another thing I'm missing? Vector. Omega should be a vector. Okay. Now we can substitute everything we know about VA, VC, and RA/C. First, let's look at RA/C. What is RA/C? RA/C, it's a vector start from C pointing to A. So it would be that vector there, straight up from point C. This is RA/C. We know the big radius R and small r's. So what is RA/C in a Cartesian coordinate system? Straight up means you only have j components. How much on j? Big R minus small r should be the distance from C to A. So RA/C is big R minus small r on j direction. Omega can be written as a vector, omega on k direction. That's the angular velocity. VC is 0, no matter which direction you're looking at, VC is 0. VA can be written as VA x direction plus VAY on j. VA is given. Okay. So now let's all look at this. What is this? You have a vector on one set of equation, you have another vector on the other set of equation. That is called a vector equation. So when we have vector equation, what should we do? When we have a vector equation, we can break it down to two scalar equations. Okay, make sure you write that down. That would be a very common method we use for this course. We always, whenever you have a vector equation, we always want to break it down to two scalar equations. So break it down to two scalar equations on I direction. We have VA equals, oops. That's, before I do that, let me just write down what is the result from this cross product. This will give you negative omega r minus ri. Okay. Now we can keep the same. Okay, now we can write down the scalar equation on I direction. VA gonna equal to whatever is in front of I. VA equals negative omega r minus r. That's the first scalar equation. On J direction, we have VA y equals of 0. That's our second scalar equation. So what we did, break this down, this vector equation into two scalar equation, 1 and 2. If we look at the scalar equation on I direction, the first equation, VA is given, R is given, small r is given. This omega is the only unknown. So we can use that to find out what is omega. Omega can be written as negative VA over r minus r. That's the first answer we're looking for. Any questions? Well, we didn't really use the second scalar equation, but if you use that, you find out a VAY is 0. Okay, now let's look at the second question. We also want to find out what is this VO, the velocity at the center of this wheel. How should we do that? Use the velocity equation again, right? We are looking for a velocity at point O. We know a bunch of information about point C or point A. So you can either pick A or C to find out velocity at point O. Okay, let's use point O and point C. The velocity of point O, apply the velocity equation, gonna be equals VC plus omega cross product RO slash C. What is RO slash C? It's a vector. Draw that vector on the diagram. RO slash C. Point O, it's over there. So RO slash C, it's a vector starting from point C and pointing to point O. So that vector is only on J direction. The distance on J, it's big R. So this guy is big R on J direction. VC is 0. VO is something we're looking for. Okay. Now I want you to do this practice on your own. Do the cross product and find out an expression for VO, a symbolic expression for VO. Okay, the cross product of omega k cos rj, it's negative omega r I. How many of you got that right? Raise your hand. Okay, good. That's the correct result from that cross product. Now we have this expression for VO. We solved omega previously, so we can plug in what is that omega. Plug in omega, have negative VA divided by R minus R times R on I direction. Then negative becomes positive. So there we have it, VO. The vector form for VO is VA divided by R minus R times big R on I direction. Okay, that's all about this example 2A6. All right, now let's watch a video. I know the no slip is kind of hard to visualize. Let's watch a video to visualize this no slip condition. Okay. Sure.